So it took us a year rather than the 2 to 3 months that was implied by the previous slide. Where did we get caught up? Well, we ordered some of the wrong parts. Now that, I think, falls into the category of the bill of materials that are available on different people's websites not actually being accurate. So you could buy something and then find that you needed 7 instead of 2, or. And those are things where really feedback's required, but as soon as we looked at feeding back on things like that, you emerged they're working on the next model, so the bill of materials is going to be different, and there's a tremendous rate of change at the moment. Then another thing that cost us quite a lot of time was backing the wrong technology, and a couple of instances of that, one in the hardware category, one in the software category. The extruder, I mean, I don't want to be pejorative about getting the frame to work, but the extruder basically is the difficult bit. The frame, the stepper motors, etc. Tried and tested technology. We bought the wrong sort of extruder. We bought the standard extruder off the RdgGeek site after several weeks of trying to get it to work. It produced prints, but they weren't very good quality. On discussion with the more experienced builders, get yourself a different sort of nozzle and heater element. And once we did that, we were away and running really. And software, similarly, we spent a lot of time trying to improve the quality of the print using the software that's part of the RdgGeek project. Somebody said on a website, why don't you use ScaneForge, which is a different software package. We used that, print quality improved 2-3-fold. But even allowing for the fact you've got all the right technology, the fine-tuning, still takes a while. So when we were talking to people early on, we got a lot of questions about how do you produce things. Well, you need a design, which you can produce in any one of a myriad of design programs. Particularly we use OpenSCAD, which is a system where you actually declare what you want. So you say, I want a disc this size by that size positioned here, and then I want to put a tower on top of it this size, that size. And you just specify that as equations. It's like a programming language. So for those of you who are software people, you can code your 3D shapes. Another one we've played with, mainly because it has the, I think the most intuitive user interface, is Google SketchUp. But there's a bit of a gotcha that you have to do something with Google SketchUp to get to the next stage. And then there's another program called Blender, which, in my observation, you need about a 3-month training course to be able to use the program. It is incredibly powerful, but it's not a shallow learning curve. So when you've got your 3D object in your on your computer screen and you've looked at it from every angle and it's what you want, you then output it into a format called STL. And STL is basically the description of the object in triangles. So it's a particular format. And the reason you need it in STL is because STL is the standard format that gets converted to the language the machine understands, which is a thing called G-code. So you have to go through these processes, and one of the things that can happen between here and here is the program outputting the STL can get some of its triangles the wrong way around, which then makes the object impossible for the conversion to understand. So you need to check and verify you've got decent quality STL. Then you send it off to the machine, and depending on the size of the object, an hour to 3-4 hours later, you've got the object sitting there on the machine printed out. So, apart from designing better mousetraps, there are lots of ways you can come up with objects to print, and they fall into 3 categories. I've talked about the designing ones, so you've got SketchUp, OpenSCAD and Blender, and there's a list that goes on here too. If money's no object, you've got AutoCAD up the end here. You can also go to this wonderful place called Thingiverse, and that is the are there social media people here? Are anybody into social media? Yeah, okay. Well, I would describe this as the useful end of social media. Because you can go there and you can actually get things that people have designed before and save yourself an awful lot of effort. And it's growing all the time, it's growing like topsy. And if you're into that sort of stuff, you can lose yourself for days just looking at other things that people have designed and wonder if you want to print them out. But another interesting way of achieving objects to print is to scan them. And one of the potential applications for these 3D printers is actually repair. So I've got one of these that, for the sake of argument, happens to have fallen off my pick any antique car, let's say Morris Minor. You stick it on, glue it back together for the purpose of scan, stick it on the turntable. This thing scans it in 3D, outputs an STL file, print it off in plastic, take it down to your local foundry, say, can you cast me one of those? It takes the plastic, slaps it in some sand, pours hot metal in it, the plastic evaporates, and you've got a metal replacement part. So, I think scanning is an area whose time has to come, and there's loads of applications of that, and that's where I do think the intellectual property argument comes in. So has it been worth the effort? Well, I must admit I think it has. I'm not sure Hannah would agree, because I just sat there and watched her do most of it.
Do you let her wave sometimes?
Sorry?
I said, do you let her wave sometimes?
No, she's nailed it home until she's got this finished and working in the second machine. But I think what we've got out of the process is whereas when you watch the TV programs or you read the enthusiastic websites and commentary of some of our friends in the media, this stuff seems to be a piece of cake. And I think what it's given us over the last year particularly is the streetcraft and the know-how. And I think some people, and I'm quite pleased it's been us, some people have to get that knowledge of streetcraft to improve it and to make it more accessible for the next generation and the generation after that. And I think it won't be long before the equivalents of Hewlett and Packard are cranking out these machines in their garages. So just to finish off, a couple of questions by way of market research. Not that we would necessarily want to do either of these things, but I oscillate when we get response when we talk to people like we had over in the corner. I think the world is the lobster for 3D printers. But if you're talking about spending £500–600 to buy a reliably working one of these, would you buy one? Yeah. Yeah. Okay.
Possibly.
Yeah. Well, I mean that's and secondly, if you weren't into buying one, would you actually go to the trouble of learning how to design items using the programs and possibly?
Yeah.
Sorry?
If you bought one, definitely.
No, I'm talking about if you wouldn't buy one.
If you wouldn't buy one.
Yeah, I mean, I know a number of people who would say, I love the concept. Judging by what you've been through, it's far too much hard work to run one of these yourselves. Because also, when you've got one, it's got this hot bit and these moving bits, and they wear out. This is not silicon, wearless. Once you've got it, it just works reliably forever. You've got a maintenance work, my dear. And I know other people who say, well, I don't want all that grief, but I would. If there was a bureau locally, I'd come to a bureau, and I'd bring my files, or I'd email my files or whatever, and I'd have them printed out. And there are websites, I mean Shapeways and Pinocchio are sites that do this now, but they're big industrial scale in other countries. Sorry, you got a question?
No, just as you said.
Oh, right, yeah, good man.
What are the material costs like?
The bits that are going
to produce that bearing.
To produce that bearing, I think that's about £3.50, £4.
Right.
I mean, the PLA is reasonably cheap, so you're not talking huge amounts of money, but it does have its limitations as a material if you're going to use it. Okay, well, thank you for the feedback. I hope I haven't gone on too long. And if anybody's got any questions, and we'll hang around for as long as they'll let us if people want to talk about the machine afterwards.